Hello, curious minds. What if I told you we could turn the barren red wasteland of Mars into a thriving green paradise? Could humanity create a second Earth, and should we even try? Let's face it, Earth is pretty great. We've got breathable air, drinkable water, pizza delivery. What's not to love? But here's the thing, we're putting all our eggs in one fragile basket. One good asteroid impact, one runaway climate disaster, and it's game over for humanity. That's where Mars comes in. Think of it as a backup drive for life as we know it. If we can establish a self-sustaining human presence on another planet, we increase our chances of survival in the face of existential threats. It's like having a spare tire in your car. You hope you never need it, but you're sure glad it's there when you do. But it goes beyond just survival. Imagine the scientific discoveries waiting to be unearthed on a terraformed Mars. We could study the origins of life, unlock the secrets of planetary evolution, and gain unprecedented insights into our own planet's history. The knowledge we could gain would be invaluable, expanding our understanding of the universe and our place within it. And let's not forget the spirit of exploration that burns bright within us. Humans are explorers by nature, driven by an insatiable curiosity to push beyond the horizon, to chart the unknown, to boldly go where no one has gone before. Okay, let's get real for a moment. Transforming Mars into a second Earth is no walk in the park. We're talking about a planet with an average temperature of -65°C, or -81 degrees Fahrenheit, and a thin atmosphere composed mostly of carbon dioxide, which is unbreathable for humans. You see, Earth's atmosphere is like a warm, cozy blanket, trapping heat from the sun and keeping our planet at a comfortable temperature. Mars' atmosphere is less than 1% as dense as Earth's. Because of this, it can't hold on to heat, so any warmth from the sun just escapes straight into space. Without an atmosphere to trap that heat, the planet stays frozen. Plus, its thin atmosphere causes extremely low pressure, which prevents liquid water from existing on the surface. One way to fix both the thin atmosphere and the cold is to beef up the atmosphere itself. So, we need to thicken its atmosphere and increase its greenhouse effect. That means releasing massive amounts of greenhouse gases like carbon dioxide and water vapor into the Martian atmosphere. Now, where are we going to find all that gas? Well, that's where it gets really interesting. See, Mars actually has a lot of carbon dioxide frozen beneath its surface as ice. If we can warm the planet up just enough, maybe by using things like giant mirrors or controlled explosions, we can trigger a runaway greenhouse effect, releasing all that CO2 into the atmosphere. Sounds simple, right? Well, not so fast. Another idea is to bring in gases from somewhere else. We could try to redirect nitrogen-rich asteroids or comets to Mars to add the gases needed to thicken the atmosphere and make it more Earth-like, though this would require incredible precision and energy. Instead of waiting for natural gases to do the job, we could create our own greenhouse gases like methane to help warm things up. These gases are super effective at trapping heat, so even a little bit could make a big difference in raising the temperature. Speaking of warming things up, let's talk about water. We know that Mars once had flowing rivers, vast lakes, and maybe even a giant ocean covering its northern hemisphere. Today, most of that water is locked away beneath the surface as ice, with some escaping into space as the weak atmosphere slowly dissipates. To make Mars a truly habitable world, we need to find a way to unlock those ancient water reserves and get them flowing freely once again. This will require a combination of ingenious engineering and a bit of planetary manipulation. Imagine using giant orbital mirrors to focus sunlight on the Martian poles, melting the ice caps and releasing torrents of water into the thirsty landscape. So again, using mirrors or controlled explosions to heat the poles could release water vapor and CO2, thickening the atmosphere and creating a hydrological cycle. Another possibility is mining subsurface ice. Robots or drills could extract ice from underground reservoirs, though this would be energy intensive. We could also import water with redirect icy comets to crash into Mars. It's a bold idea, but one fraught with technical challenges. Another problem is radiation. Mars lacks a protective magnetic field, exposing the surface to intense solar and cosmic radiation. This isn't just dangerous for humans, it could strip away any atmosphere we create over time. What could be the solutions? In the short term, humans could live underground or inside lava tubes to shield themselves from radiation. As a long-term fix, scientists have proposed creating an artificial magnetic field. For instance, placing a powerful magnet at Mars's Lagrange point, a stable spot in space, could protect the planet from solar wind. Another intriguing idea is to genetically engineer plants, microbes, or even humans to withstand higher levels of radiation. While it sounds like science fiction, advances in biotechnology might make it possible. Terraforming Mars would require vast amounts of nitrogen, water, and energy, many of which are scarce on the planet. Transporting them from Earth would be astronomically expensive. To minimize reliance on Earth, we'd need to build self-sufficient factories on Mars. These could extract and process local resources, such as mining Mars's surface for materials to build habitats or generate power. Asteroid mining is another possibility. By harvesting water, minerals, and gases from asteroids near Mars, we could bring in the resources needed to support terraforming projects. On the energy front, advanced technologies like nuclear fusion could provide the power required for large-scale transformation. Okay, so we've warmed up the planet and thickened the atmosphere, but we've still got a big issue: building a functioning biosphere. For Mars to be habitable, we need more than just breathable air and water. We need an ecosystem that can support plants, animals, and humans in a sustainable way. And that's no small feat. Earth's ecosystems are incredibly complex, and replicating them on Mars means dealing with things like soil, water cycles, and food production. Stuff that just doesn't exist naturally on the red planet. Let's talk about the possible solutions. Mars's soil is made of harsh minerals, and it's not really suitable for growing plants, at least not the way we're used to on Earth. So, we'll need to create soil from scratch. This could involve mixing Martian regolith, the dusty rocky surface material, with organic matter or importing nutrients from Earth to make it fertile enough for crops. We could also use hydroponics, growing plants without soil, where nutrients are dissolved in water to feed plants. One way to keep everything balanced in a Martian biosphere is to create closed-loop systems, where waste products are recycled back into the system. For example, plants could absorb carbon dioxide from the air and produce oxygen, while humans breathe that oxygen and release CO2. Water would be recycled in a similar way, using technology to purify and reuse it, ensuring nothing goes to waste. This kind of system is already used in spacecraft and space stations, but on Mars, we'd need to scale it up significantly. In the early stages, we might need to create controlled environments. Think giant greenhouses or biodomes, where we can grow crops and house plants, animals, and humans. These domes could regulate temperature, humidity, and air pressure, mimicking Earth-like conditions while we gradually work on transforming the planet itself. Over time, these biodomes could expand and eventually lead to larger, more open biospheres as the Martian environment becomes more hospitable. To kickstart a biosphere, we'll need to bring Earth's plants, microbes, and perhaps even insects to Mars. These organisms would help build up the soil, produce oxygen, and provide food. But this is where things get tricky. Introducing Earth life to Mars could have unintended consequences. We'd have to carefully select species that can survive the harsh conditions and avoid potentially harming any microbial life that might already exist on Mars. A careful, step-by-step approach would be needed. So, why does this matter? Creating a biosphere on Mars is essential because it would allow humans to live independently of Earth. We wouldn't have to rely on Earth for food or oxygen, and eventually we could start to see real ecosystems that could sustain life long-term. Okay, so Mars is looking more and more like a place where humans could live, but there's still a major hurdle. How do we actually live there? Mars has a completely different environment than Earth, and adapting to it won't be easy. You're dealing with extreme cold, low gravity, no breathable air, and intense radiation. So, how do we survive and settle there in the long run? We won't be able to just land on Mars and start living like we do on Earth. We'll need to build habitats that can protect us from radiation, keep us warm, and provide all the essentials like air, water, and food. Plus, humans will have to adapt physically to life in low gravity, and that's going to take some time and innovation. First problem is gravity. Mars has only about 38% of Earth's gravity, which sounds cool, right? Low gravity could make jumping higher or carrying heavy loads easier, but it's actually more complicated than that. Long-term exposure to low gravity can weaken bones and muscles. Astronauts on the International Space Station experience some of this, and it's a big concern for Mars settlers. Solution? Well, one option could be using artificial gravity in Mars habitats. This could be done by spinning a habitat to create centrifugal force, kind of like a rotating space station. But until we get there, settlers may have to exercise a lot to counteract muscle loss, just like astronauts do. Another issue is air. The air on Mars is mostly carbon dioxide, definitely not breathable for humans. To survive, we'd need to create habitats with Earth-like air. These habitats would have to maintain a constant supply of oxygen and a pressure similar to what we experience on Earth. Domes or underground bases could provide safe, controlled environments where humans can live without spacesuits. We might also have to use plants to help replenish oxygen and absorb carbon dioxide, which could kickstart a small biosphere inside these habitats. Plus, without a magnetic field, Mars has no natural protection from solar radiation. This could increase the risk of cancer, radiation sickness, and other health problems. Solution? To protect settlers, we could build habitats underground, or use thick layers of Martian soil or water to shield against radiation. In the future, we might even develop materials or technologies that provide even more effective protection, like magnetic shields or radiation-absorbing building materials. Water is essential for life, but it's not as simple as turning on a tap on Mars. In the early stages, growing food in greenhouses or hydroponic systems, where plants grow in water instead of soil, would be necessary. Over time, as the environment becomes more hospitable, settlers might be able to start farming directly in Martian soil, though we'll need to improve the soil first as it's not naturally fertile. So, how do we actually start building a settlement? Here's the rough timeline we might follow. The first human missions to Mars would likely be short-term scientific missions to explore the planet and test the necessary technologies. Think of it like setting up a Mars base camp. During these missions, we'd need to test everything from habitat construction to life support systems to resource extraction. Once we've got the basics in place, we could start building more permanent habitats. These could be inflatable modules like Bigelow Aerospace's inflatable habitats, or structures made from local materials like Martian regolith, the rocky dust on the surface. Eventually, we could use 3D printing to create structures that are fully integrated with the Martian environment. As the settlement grows, we'd expand to include more habitats, larger greenhouses, and perhaps even the beginnings of terraforming efforts. More settlers would arrive over time and the colony would become more self-sufficient. There's also the possibility of introducing robots to help with construction, mining, and farming tasks to speed up the process and make life easier for humans. Over time, the goal would be for the Mars colony to become fully self-sustaining, meaning it wouldn't rely on Earth for supplies. By using local resources like ice for water, carbon dioxide for oxygen, and even mining Mars minerals, the colony could thrive independently. New technologies like nuclear fusion for energy or closed-loop farming systems would be key in making this possible. Human adaptation to Mars is about more than just surviving, it's about thriving. As we start building permanent settlements, we'll need to make Mars feel like home, which means developing all the technologies, infrastructure, and systems that make life on Earth possible. It's a long journey, but it's one that could eventually lead to Mars becoming a second home for humanity. We've got a pretty big vision for Mars, but how far have we come in actually making this happen? The truth is, while we've made some incredible progress, we're still in the early stages. We've sent robots to explore, tested some key technologies, and even talked about colonization, but we're nowhere near ready to pack our bags and head to Mars just yet. So, what's been done so far? And what's coming next? One of the biggest breakthroughs in our exploration of Mars has been the success of rovers like Curiosity, Perseverance, and the Ingenuity helicopter. These missions have helped us understand Mars's surface, its geology, and its potential for supporting life. NASA's MAVEN, or Mars Atmosphere and Volatile Evolution mission, has been studying Mars's thin atmosphere in detail. This helps us understand how Mars lost its original atmosphere and why it's so cold. It also informs our ideas for how to thicken the atmosphere and kickstart the terraforming process. Meanwhile, the ExoMars Trace Gas Orbiter is searching for gases in the atmosphere that could indicate the presence of microbial life or geologically active processes. We've started testing technologies that would support human missions to Mars. SpaceX's Starship, for example, aims to be the workhorse for Mars missions, with its goal of taking large groups of people and cargo to Mars. We've also tested life support systems in isolation habitats like NASA's Chapia mission, where astronauts live and work in simulated Mars conditions to understand what it would take to survive there long-term. There's also a focus on how to build habitats and other necessary infrastructure on Mars. NASA has already started exploring 3D printing using Martian soil, regolith, to create shelters, tools, and other structures. This technology could allow astronauts to build everything from living spaces to research labs directly on Mars, without having to rely on supplies from Earth. Plus, in situ resource utilization, ISRU, is a huge focus. Essentially, how to use local materials like water ice or CO2 to create oxygen, water, and fuel, rather than shipping everything from Earth. The next big milestone is sending humans to Mars. NASA's Artemis program is working on returning astronauts to the Moon, and this is seen as a stepping stone for future Mars missions. NASA plans to send the first humans to Mars in the 2030s, with an emphasis on learning how to live off-planet for extended periods. SpaceX, under Elon Musk, is working towards SpaceX Starship missions to Mars, with the goal of establishing a permanent colony in the not-too-distant future. SpaceX aims to make life on Mars more sustainable and eventually self-sufficient, with the hope of transporting people to Mars regularly in the 2040s or 2050s. While humans won't be terraforming Mars overnight, researchers are already looking into methods to begin altering the planet's environment. This involves testing ideas like creating artificial greenhouse gases, which we talked about earlier. Looking further ahead, the vision for Mars is to establish permanent settlements that are self-sustaining. Space agencies like NASA, private companies like Blue Origin and SpaceX are working on technologies that will make these settlements possible. This could include independent power sources like nuclear fusion and closed-loop life support systems that recycle air, water, and food. Long-term plans for terraforming Mars may take centuries, but the seeds for this effort are being planted now. While it's hard to predict exactly when or how terraforming will happen, some experts believe we could start small-scale terraforming experiments within the next 100 years. Mars is filled with challenges that will test our ingenuity, patience, and values as a species. First up, money and materials. Turning Mars into a second home won't come cheap. The cost of developing the necessary technologies, launching missions, and building a colony could run into the trillions of dollars. On top of that, we're talking about transporting enormous amounts of equipment, resources, and people across millions of miles of space. The big question, who's footing the bill? Governments, private companies, or international partnerships? And how do we ensure the effort remains sustainable in the long run? Next big challenge is technological limitation. We've come a long way with robotics, rockets, but let's face it, most of the technology we need to terraform Mars is still in the concept stage. Massive projects like creating an artificial magnetic field, warming the planet, or building huge domes for habitation are challenges that demand innovation at a level we've never seen before. Terraforming Mars isn't a weekend project. Even with the best technology, we're looking at hundreds, if not thousands of years to make Mars truly Earth-like. That's a hard sell for people and governments today, especially when the payoff might not be seen for generations. Then there's the big, what if? What if Mars already has microbial life? Do we have the right to terraform and potentially wipe out native Martian organisms? On the flip side, do we have a responsibility to expand life beyond Earth to ensure survival in case of a global catastrophe? Plus, Mars isn't just tough on technology, it's tough on people. Low gravity, isolation, radiation exposure, and limited resources could take a serious toll on mental and physical health. How do we keep settlers motivated and healthy in such an extreme environment? And what happens when humanity's natural social and political issues start showing up in the colony? Building a thriving society on Mars will require more than just science. It'll demand cooperation, governance, and perhaps even new systems of living that prioritize collective survival. Let's say we manage to warm up the planet and thicken the atmosphere. What's stopping Mars's volatile climate from undoing all our hard work? Without a magnetic field, Mars is still vulnerable to solar winds that strip away the atmosphere. Even with terraforming, maintaining stability could be a constant uphill battle. Thanks for joining me on this journey to the Red Planet. We've explored the science, the challenges, and the possibilities of transforming Mars into a second Earth. But the real question is, should we do it? What do you think? Is terraforming Mars humanity's next big step? Or should we focus on saving our home planet first? Share your thoughts in the comments. And if you enjoyed this exploration, don't forget to like this video, subscribe for more fascinating deep dives into science and space, and hit that bell icon so you never miss an adventure. Thanks for watching. Until next time, keep looking up.